Question 2. So it shows you that in this graph, it's position versus time. So in this graph, it shows that shown here, the velocity is positive. So we're going to do blue for velocity and A for acceleration. So A, red for acceleration, blue for velocity. Position versus time. This shows that the acceleration is positive and the slope is also positive. Here, you see that the velocity, let me find my pen, the velocity equals 0. Because now the velocity is at a standstill and then it will go downward. Once you realize that this will show once the velocity reaches the 0, you know that it will go down also because of gravity, but it will travel downward because the slope is going down as well. So because the slope is becoming negative, this shows you that velocity is negative as well, because when we go back here, it shows you that the slope is going upwards, it's positive. Once it hits its threshold, once it hits its maximum point, the slope becomes the velocity becomes 0. Then as it's coming back down this way, the velocity becomes negative. If you look at a scale, for instance, an example, if you look at a regular, X and Y triangle, Y axis, you know that going this way is positive, going downwards is negative. No matter what side of the graph that you have, you know that even this side is negative on the x-axis, but it's also positive on the y-axis, the same as here. It's positive on the x-axis, but once it's going downward, it's negative on the y-axis. The same thing applies when you're looking at the slope. We know that velocity is the measurement of slope. So we have delta x over delta t. And that will be position of an object as a function of time. Where we know that the velocity over time measures the acceleration. So when we look at our options, it asks, okay, the first one, in region 1, the velocity is positive and the acceleration is negative Meanwhile, in region 5, the velocity is negative and the acceleration is positive. Well, we know that A is false because in region 1, the velocity right here is going up. So in region 1, we know the velocity is going upwards. And we also know that it's the acceleration is also positive. And 2, so we can exclude that automatically. Usually when we read it, with what I learn is you just, take away the ones that don't make sense. Region 2, the velocity is negative. Automatically cross that out because we know that now the velocity is going upwards. Once it hits between 3 and 4, it has reached that 0. The velocity becomes 0 because the slope has reached its highest point. In region 1, positive, meaning the position is negative. We also know that it's false because in region 1, the velocity again is going upward. So B and C are automatically eliminated. Our choices will be between A and D. Let's read D. In region 1, the velocity is positive and the acceleration is positive. Meanwhile, in region 5, the velocity is negative and the acceleration is positive, which is true because we know that the total velocity over the total time equals acceleration. We also know that in region 1, the velocity and acceleration is going upwards. So I think if y'all remember when the professor did this, and when he had something like this doesn't change. The velocity will not change. Even though this is not the same as that graph, I remember it this way because I understand that if the velocity is going up, the acceleration is going up, and they are both positive. Now, if the velocity is negative, which shows in region 5, the acceleration is still positive because it's traveling this way. Let me put in yellow. It's traveling this way, which is positive.